All right, can I get somebody, actually, I may be able to do a live test here, but I just want to see if their audio. The last time I tried to record, it was audio madness. Let me see, check. Okay, yeah, I got audio on YouTube. Okay, all right, I think this is going to work. So what I'll do is maybe just send out a note to everybody. So the way I'm doing this, it's all madness. I'm using the podium as an external monitor. Um, so I don't actually have, I'm literally, actually, I'm not even, I'm bypassing the podium. I am using the projector as an external monitor. And running everything from my laptop. And then if you go to YouTube, if you go to my YouTube channel, and then to get audio, so no matter where I move, I've got my ear pods in, which is transparency mode, so I ought to be able to hear you, but it's still, to me, it's always a little bit obscured, even when you're in transparency mode. But that's so that I've got audio hanging with me. When I tried to go remote to the laptop, I had problems last time, and the YouTube video for 2810 showed up without sound, which kind of defeats the purpose. Then I've got OBS streaming, which allows me to have the slides, the external monitor, and the live camera, plus the slides, plus when I get a Discord channel, we'll be able to drop Discord chats in the same stream. So, alrighty. Yeah, so if anybody wants to like live test and just go check on my, you guys just go to YouTube, search for Charles Knudsen, spell it correctly. It'll be pretty obvious. And if we had a Discord channel, then I could drop the other stuff on it right now. So it's actually really weird, and I sound weird in my own just because of these guys. And that's worse. That's all I got. Okay, anyway, we're just going to try it. Oh, and there's actually one other trick that I wanted to do. What's that? Looking good on YouTube? Okay. And I mean, the reality is I want to be sensitive, right? I mean, in these days of stupid COVID madness, you know, I'd like to be in a position where anybody who feels less comfortable about being, you know, in the physical classroom wouldn't have to be. You know, I mean, so I don't know how the quality is on this, but we're just going to try it. And the other problem is I've got a slide advancer, but I have to be centered on the slides to advance it, so I can't calibrate what the audio, what the video looks like. Anyway, it's a mess. Okay, so couple things. I've been having an experience with this class. You know, everybody knows how I got here, right? By what's the right word? Against your will. Loosely against my will, but with some cooperation, because I could have just said no. I frankly refuse. And one of the things that I'm struggling with, honestly, is probably what you're struggling with. I'll give you just an example, and I'll explain what I'm going to do because I'm going to try to make a few changes. But this class is just absolutely kicking my butt in a bad way. Because here's why. Here's lecture 4. Happy lecture 4. You know, ARP and DHCP. These are not hard ideas. You know, I mean, I can give you 30 seconds on each one, and you would have probably whatever is going to actually stick for the rest of your career in like 30 seconds. And then, but instead, what I get is I added that for background, then I added that for background, and then that's where the slides start. I added that and that to helpful, then this was what was there. A little, it's like Bambi versus Godzilla, right? Then it's like, where are we at? Come on, man. Okay, I'm gonna blind myself now. Now the thing stops. Great. Blowing. Oh, it's because Fortunac just showed up and wants to know all about me. Thank you, Fortunac. I don't know what we would do without your name. Probably actually may have some progress or something. Okay. No, really, I mean the moment. It was just taken from me. No, I'm using this bad boy. Dun, 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 dun. Yeah, I just want you to understand that this is as horrible for me as it is for you. Maybe worse because you can at least just sit there and go, yeah, screw that. I'll figure that out later. I'll play Fortnite at this moment. You know what I mean? But I actually have to appear competent, at this. So it's just crap, man. And then it finally goes, da-da! So that's preview. That's spoiler. This is what we're going to talk about today. I just realized that it just sucks and I can't live this way. And so, like for example, in the book, have you noticed that the art part of the book is like page and a half? Because it's not that hard. And so what I'm going to do, and I'm just taking it's ungodly amount of time. Every Monday and Wednesday is just gone to the cause of this crappy lecture that I try to throw down for you guys. So I'm gonna change my strategy. Now I also haven't even looked at the homeworks yet. You know, I'm burning over budget. But I will. But one of the ways that I'll do that is I'm actually going to just start rolling my own slides. At this point, it's just like I can spend 6 hours trying to understand, this, or I can spend like half that and just roll my own. I mean, that's kind of where I'm at. And so I just want you to know that I appreciate your patience. Bear with me while we're all kind of in this weird mess together. Same idea. Well, I mean, the thing is, here's the thing, there is detail. There is, and you got to get down to the detail. But to me, starting with this detail, it's Bambi versus Godzilla. If you've never seen this film, you should go look it up. No, no, exactly. So I'm gonna do my best to make this without sacrificing the stuff that's actually important and valuable. That's what we're going to try. And right now, I just feel like so far behind the curve. Wait, is it Sean? No, Seth. I knew there was an S. So okay, I've got to get less animated in my persona and my voice. Okay. I one time went to an academic conference. Well, I many times went to an academic conference, but there was one presentation where you present your research, right? And there was a guy who just a group about this size, in a conference room at a conference, you know, and who literally walked up to the slides and stood like this, back to the audience, and then just subnet mask example based on Fig, period. Three. I mean, there were like voice reader programs that would have done way, way better than what this guy did. It was just like I'd never seen anything quite like that. So I don't know, some academic conference. No, no, I've been to way too many. It was just bad. It was just really, really bad. Um, okay, so let's do this thing. What we're gonna do, we're gonna wrap up a little bit of the subnet thing. We're gonna do one more subnet example. And by the way, in the book, there's a fairly reasonable subnet example that uses 24 bits, which is kind of standard. And then in the slides, we got to do a 25-bit example. I don't know, just to make the binary math hard, but I'll try to talk you through it because I didn't have the realization that I was going to roll my own until about an hour ago. I was just like, screw this. It's not working. And then, like I said, I'm going to do everything I can to make the quiz stuff, homework stuff match and be reasonable, in terms of expectation. And I don't know if we talked about this, but there's one theory of learning that somehow if you drag everybody all the way down to the atomic level of everything, that to get there you have to have understood all the concepts. And I just think that's bad pedagogy. I don't think it's true. I think usually you get lost and you can't see the forest for the trees. That's normally what happens. And then you walk away and you remember, yeah, I remember we did a lot of math. And then you're like, but what was the big takeaway? Don't take a class from that one guy. Like that's or networks are hard, or, what's that? Test taking, yeah, exactly. So I would rather, center on the concepts because I first learned this stuff a long, long time ago, 30 years ago, whenever. Um, more, yeah, 35. And there's stuff that's important that still sticks with me. And yet, when it's time to go twiddle the bits, I got to just like you go look and twiddle the stupid bits and okay, how do we do that? That's not the stuff that sticks in your head. It's the other stuff that actually sticks. So that's what I'm going to try to do without creaming myself to the extent possible. So, having given you that heads up, I'm going to try to walk through those slides because that's all we got for today. And then by Monday, I'll be a hero in my, in whatever, in my own mind at least. Um, so let's just quick review again on subnetting, okay? In the IP addressing scheme, we have laser time. Um, we have this network part of a standard IP address, okay? And then this is the part that identifies, we talked about class A, class B, class C, right? And the idea was that class A gave you, what was it? I actually have the other slides up in case I have a moment just like this, but I can't actually remember. Um, Class A was lots and lots and lots of tiny little networks. Class A was a small set of big networks, which maybe that was the original idea. There would just be a few big networks. And then Class C was a bazillion tiny networks, right? And we kind of said, well, Class B is that middle ground, but you still wind up with like 16,000 networks or nodes in a given network. So maybe we have our own way of like slicing that up. We'll take a larger network and we'll subnet it into smaller networks, right? And instead of everybody sort of conceptually on the same segments, I can put a bunch of routers. A university like this is going to have its own subnet, right? Which we talked about oh so briefly. And then we take these class B addresses and those are the ones that we do the subnetting. So all we really do is take this last part and we take some portion of it as tacked on to the network. That's it. So that is literally the whole secret. Now, to the rest of the internet, there has to be some gateway into all these subnets that I can get to from anywhere else because the rest of the internet doesn't know about your subnet. It's just going to send it to some endpoint, which is going to be like the gateway to your bunch of little networks. And it's going to look at that just like this. So the rest of the internet doesn't care about your subnets. As far as it's concerned, there's a class B network and then there's a host address. And the fact is that it's almost, this whole idea here is almost like vernacular trickery. It's the reality is, what's the difference, honestly, between saying it's 16 bits of host or it's 8 bits of subnet and host? The only issue is this allows me to break it into physical segments, with routers in between the different chunks and do my own little mini routing inside my world on the backside of my gateway. Like just at UVU, we'll have our own routers. But things coming to UVU are just going to come to, our kind of main address, really. Yeah, Seth.
So is that why subnet mask is required when you're sending stuff? Or is it
when you're setting up to receive, I think is when you set that subnet mask up, or when you're doing your own configuration of my location, my home within some network. Because when I send, all I need to know is just your IP address. And from what I'm concerned with up here, I don't see you as being subnetted. I just see you as this, and somebody has got to receive at this level here and then just go, oh, and now we've got, 2 to the 8th, right? We've got 256 from 0 to 255, right? Different subnets, each of which has from 0 to 255. But I'm managing that internally. Like here at UVU, I'm going to manage that. And outside of that, I don't care. All right. And then this again is kind of the reminder that we have this traditional notation, which you've seen, 255, basically it's a bit mask. And then this, we didn't really talk about it, but this slash notation or cider notation, all that really does is says, it's a little clunky to say all of this. Besides, it's redundant, 255.255. It's all just a string of ones. The slash notation just goes, how many ones are there? If there's 24, then it'll be 8 times 3, that's 24, and then that'll just be 0, okay? We're going to do an example with 25. It doesn't really matter, right? 25 would include this in the bit mask, right? All right, let me see. So yeah, here we go, into the scary domain. So, once again, when you're doing these kinds of crazy, absurd graphics, the key is to just tease it apart. Just look, just stop, and the slide's not helping you, so we have to help ourselves, okay? Just understand it is as ugly for me. And by the way, really, we didn't have room to put another A and an E, or an E, sorry, an E and an A and an E, and give us, interface instead of, I don't even want to pronounce that, Or you could just change INTR for cluster, then you would describe these slides. You're welcome, YouTube. Okay, so what's going on here? Let's start with things we know. H's are hosts, right? H1, H2, H3. These are just nodes. These are endpoints for the sake of our little experiment, okay? R's are the routers, okay? Now, one of the things that we're doing is, remember when we did you remember last Wednesday? We did this thing where we would say like network adapter 1, network interface 1 or 2, that kind of thing, right? And that's what we did. We spelled it out, but like interface number 0, interface 1. But the reality is that there's actually an IP address, okay, that refers to that interface. Okay, and that's what we're doing here is opening that up a little bit more to you. This idea that up here there's a subnet number, which is the number that's sort of, known to everybody else. And then underneath, I'm going to tack on like, dot 15, dot 1, dot 129, dot 14. And we're going to talk about this, but we're actually /25, which means that we have 25 bits of bit mask, okay? So in other words, the subnet mask, where is it at? Yeah, right up here. That subnet mask, when you say /25, it's actually right there as well. 255.128, which means the leftmost bit is on and then the 64 is 0, the 32 is 0, the 16 is 0, the 8 0, the 4 0, 2 0, the 1 0. Okay, so it's 128 because it goes, all 8 bits, that's 255, all 8 bits, 255, all 8 bits, 255, and then 1 bit, that's 128. If you got, 1 bit and the rest are zeros and you've got 8 of them, that value is 128. So it turns out that this is slash 25 is a shorthand that says 25 ones, and I don't know which one is more obtuse and unhelpful, but the alternative would be to literally draw out 1 1 1 1 1 1 1, little space for clarity, 1 1 1 1, you know what I mean? That would be worse because both of these are trying to represent that, okay? All right, so what we're doing now is we're basically saying that the blue horizontals are networks. They're little networks connected by routers, right? So that there's that network connected by this router to this network, and this router is also on the same network. And then that router is also on this network, right? Routers need to be on multiple networks at the same time, right? And so what else is important to talk about here? Let me see. Well, we can get the party started here. So that I mentioned before, that's the traditional notation. That's the slash notation, which tells you the number of bits. So that's how you remember that. Now, this is the other kind of key. What's viewable to the rest of the internet, for everybody on this thing, the internet thinks that they're at 128.96.0.0. It's a nice, happy Class B address. Somebody has to be that sort of receiver who can take that and then put it onto the local nets. Then the routers can move it around campus. If you want to think of it as, every department has their own network and there's routers in between, someone's got to be addressable out here, and be receiving for the university. And then, that's the network address for everybody, right? Underneath that is the host. So as far as the rest of the world is concerned, the stuff that comes in here is just the address of an individual node. We just happen to know that it's going to be a network plus a node, all kind of squeezed into the same space. Okay. All right. So what we're trying to do is send a packet. So right here, this guy right there is the packet we're trying to send. So check it out. Now, there's one other thing, and this is really important, and it's a foreshadowing for ARP. And for DHCP, which will come later depending on time. But when you're sending packets, and this is kind of networks one, you're not sending packets to hardware addresses, okay? It would be a little bit like this. If you guys live, I don't know where everybody lives around here, but let's just say that, I don't know, you live near Center Street in Orem, right? You're at an apartment building and you're like some house and it's whatever, 125 north and 200 west, right? Here in Utah, we have the Cartesian coordinate system. That is not actually your physical location. It's a representation of a physical location. It can get to you. The mail can get to you. But if they suddenly changed the street names and you kept your physical location, right? They said, we're not going to use a 200 West. It's all just too Cartesian. We're going to now just go, Mombasa Street, and that used to be 200 West. The addressing can change, but the reality is if you take GPS coordinates, latitude, longitude of the center point of your house or the front door or the mailbox or whatever, that's your actual sort of MAC address. That's your physical address. Then we apply a name that just kind of lets you kind of get there, right? And you can play games with this if you want, like the street could be viewed as like the network and the house address could be like a node on that subnet, that kind of idea. and you start by taking a zip code. It's really the same idea, right? Take a zip code to get you to that part of Orem. Take another chunk to get you on the right street. Another, another one to identify the particular house. But that physical spot on the planet is defined in sort of universal terms via GPS coordinates, right? That's like your MAC address, your physical hardware. It's not about location, but it is about, yes, you are who I am ultimately trying to talk to. But that's highly impractical. I mean, early networks actually did that. Let just give me everybody's address. I know who everybody is. Everybody's like social, or their DNA imprint. I don't know. Their DNA mapping. I don't even know anything about DNA, right? Not really. I know it's different from RNA, but somehow are involved and related. I don't know. Um, but no, you know what I mean? It's something that identifies your device uniquely in the whole world. So I can at some level say, I know I'm talking to the right person. But we talked about last time the impracticality of trying to just have a table with like the physical address and how do I get to everybody on the planet. Besides the fact that there are needs to move around, right? For example, talk about from a routing perspective. I am today, just on my laptop, I started off the day in my home office, right, with a certain IP address that was given to me by my um, service provider. A dynamic, this is the DHCP foreshadowing, a dynamic IP address that was given to me. Then while I was being actually getting a ride here, I'm on my phone, tethered to my phone with a different IP address. And then when I get to my office and I plug in, I've got a different IP address, you know? And so, and again, like my other device, like my iPad, starts off on the Wi-Fi, which is not the same as the wired IP address, you know, and there's a lot of IP addresses bopping around. And the whole idea is that we can work with the IP addresses as long as someone goes, I know about that IP address, you know, and when I get all the way really close, I can say, yeah, I can get it there for you, you know. But the reality is, my laptop right now has an IP address related to the physical Ethernet, which is not the same as the one in my office, not the same as the one on the Wi-Fi, not the same as the one when I was tethered or when I was on my home wired or my home wireless, right? So I probably have had 5 or 6 IP addresses today on that same laptop. But the MAC address, which is uniquely identifying the hardware, never changes. So ultimately, we can always get to me, but there may be confusion as we move around, right? Yeah,
I was just gonna say that maybe to help your analogy out a little bit, the MAC address is more similar to your social security number. It doesn't tell you anything about where you are. It
right.
tells you exactly who you are.
Or even what name you're going by.
Yeah.
You're right. You can operate under an alias. You can get married and change your name. You can change your name anytime you feel like it. Right? But that somehow, again, that's artificial in the sense of assigned by the government, but MAC addresses on your hardware are artificial anyway
Yeah.
because they're assigned by the company, right? It's like an ISBN number on a book. Same idea, right? Companies have blocks of ISBN numbers, and as they publish books, I had a publishing company once. Um, Core philosophy: if you want to just have a cool idea and try something, just go do it, and then if you fail, it's cool because you had an experience. But I have like 8 or 9 leftover ISBN numbers if anybody wants. So that's actually not true because I have to go dig it back up. But I did have a block of ISBN numbers. And if I'd published that many books through my company, then they each would have gotten a unique ISBN number. You can't be doubling them up, right? Even though the titles can sometimes change, ISBN number stays the same. I don't know if those are helping or hurting in terms of, comprehension. But in any case, here's our packet, right? And when we're bopping these packets all around, we don't lead with the machine address. We just send it to an IP address. Okay. Um, it's a little bit almost like I'll be an example. It'd be like having letters. This would be creepy and really big brotherish, but it would be like having letters that you could deliver just addressed to your name, and somehow, no matter where you were, it would kind of get to you. But we have that. We call it email. So the internet actually accommodates that. But imagine that the U.S. Postal Service was like, somebody knocks on the door, hi, Mr. Knutson. Yeah. So I know it's phone sales. Yeah, letter for you. And that would be creepy. Like but our email actually does that. So is that creepy? I think if we're thinking about it, it's at least a little creepy, you know? Um, okay. So we got this IP packet, and we've got um, this source address, which is the IP address of where it's coming from, and a destination, which is the IP address of where it's going to. And then after this is just payload, just the stuff that's being sent in this packet. All right. So this guy there is right there, 128.96.34.15. So this is the sender. H1 is the sender. The destination, 128.96.34.139. It took me like 3 minutes on this stupid slide to find that information. I'm helping you here. This is the receiver. Why it's not red, I don't know. And this box was not circled, by the way, either. But this is the premise of the entire slide. Ah, man. Anyway, so what happens here is this little bit of binary math going on here. Why? Can somebody explain something to me? Why is there just a burial ground of chairs? I don't understand it. Okay, so again, H1 is the sender, 128.96.34.15. And there's that address right there. We're going to break it into binary. That's 128.90. You can do the numbers yourself if you want to. 96, 34, and 15. Okay? Now, the subnet, the class B, gets us this part, but the subnet is right here. And then what you can see is that 25 gives you all 24 of these plus one. So that's the mask for the subnet that I apply to this guy, okay? Now what happens is, of course, what's relevant is that all of that stuff stays, but this stuff goes away. And the other thing, it's a horrible slide. Because if you look at it, all that really happens is that this part gets cleared. So why don't we call that out in the slides? Wouldn't that be helpful, right? All we really did was took the host component and cleared it. And everything that was left was the network. But because this is the standard, this is then the subnet. It's the part beyond the general purpose, generic, globally visible network, right? The globally visible network is 128.96.0.0, and somebody's set up to receive that. Somebody in that organization is set up to receive that. We then just scrub all that away, and when we're done, we get 128.96.34.0, and that's the internal subnet address. Or put another way, it's what we're referring to it inside. The outside world thinks that all of this is a host. See what I mean? The outside world thinks that's all a host, but it's actually a hoax. See what I did there? And so the reality is that internally, that's another network, and that's our host. Okay? So the 34 becomes, well, if the 34 plus, that can come into play as well. All right? Is everybody kind of following? Yeah.
Does the subnet mask unique to each network then, or
Is it what?
like unique to each network then, like you can make that whatever you want for your network, depending on how you want to?
As long as you're starting from the same network, global network address, and then you've got different subnets, but obviously the 9-bit subnet could be the same subnet on a bunch of other class B, public addresses that are not 128.96. Makes it.
That two people probably want a lot, which obviously is the ones, but I just wondered if like that's a standard one to use for most networks, like the .128, or if that's
Yeah, no, no. This just happens to be the one that we're just using, and I think it's based on the UVU one. I don't even know. I haven't really gone deep on the UVU thing. And I thought that UVU was like a /24. I thought it's in the slides from last time. But all right, but so everybody got that. So all that's really doing is telling us, and I don't know, really, 2810 is a prereq. Come on, folks. This is the generic truth table to remind us how to do an and. So we've got all that. Yeah, oh my gosh. So we got all of this coming, but we're going to burn space to remind you anyway. Sorry, I teach 2810, so I'm like living and breathing this thing every day. So I'm shocked and offended. I might even just leave. Just that's right. That's right. There'll be a cascade of professors. What happened to Dr. K? He had enough. He got to this slide right here and he just hung up his cleats. Yeah. Okay. So it'll be cool. That's our subnet. And we're still in the act of trying to send a packet from over here to over here. Now, we're going to break this down. So the rest of this, notice that the rest of this, that just kind of stays. Now, why does that need to stay? Bad slide design. I put that bracket around this guy just to remind us what we care about, and the fact that what we're going to do is kind of like we did with forwarding out in the internet, but now we're almost like, sometimes they refer to it as an intranet. It's like an internet, but it's now we're inside behind some gateway, to get into our little world. We're going to have our own routers, our own stuff, but they're still going to be running IP. They know how to do it. But the math is different, right? You're looking at a different part. I mean, at some level, you're really just looking at a different part of the address. It used to be you'd get to us by bopping around the internet, and then once you were there, you were on the same network, so you could go, "Hey, is there a Fred Jones here?" And then somebody would go, "That's me," and you give it. But the reality is there might be just thousands and thousands and thousands of nodes on a bunch of hundreds of networks. So I've got to continue routing. You know, it's a little bit like, mail comes to UVU, then there's like mail stops. Oh, Chuck's, don't ask me what my mail stop is. M something. M for, I don't know. I don't know. I really don't. And I don't care because mail, it's so archaic. It's so quaint. It's so physical and tangible. Um, okay, so here's what happens. So D is our destination IP address. Okay. Um, Now, we have to still have, remember we talked about before, everybody's got to have a forwarding table, right? We talked about this last time. You got to be able to go, because everyone's going to like see stuff and they need to know where to send it next, how to forward it, right? Routers have to have that. And even hosts at some level have to be able to go, all my packets go out to, a certain router. But I could be a host with two different routers on the same physical segment, right? I mean, I could be, where's an example here? There ain't one, but we had some last time, right? Where I'd have more than one router that I could see. And depending upon where I'm sending something, I would know, send it to Fred, send it to Jane, depending upon what it is. So I take that destination IP address and I apply the subnet mask. So I AND it. I AND the subnet mask with the D in order to get just the network, okay, to strip it off. The subnet mask, right, is 25 ones and 7 zeros. And that's what that is, okay? And so when it talks about D1, it's more like, hang on, I went crazy for a second. It's more like D prime, you know what I mean? It's like you started with D and we did something to it. And all we really did was stripped off the host address. We just stripped off the node. I just want to know what the network address is. Okay, the little subnetwork. And again, subnet means the network inside my little organization. And then let's see, what are we doing here? If when we're done stripping that, it's a subnet number, then I got a couple, then it's like a valid subnet. Then I've got to decide, is that next hop? What's my next hop? Is that an interface? If it is, I'm going to just give it straight to the final destination. Otherwise, I got to hand it off to somebody. I mean, it's pretty straightforward. I strip away the node address. All I'm left with is a destination subnet, and it's not mine. Well, it actually one of two options. It is mine. Oh, that's my subnet. Fred Jones, right? That's what happens next. It's not my subnet. I got to give it to somebody that can do something with this. Here, hey, Bob, would you mind taking that and running with it? That's it. That's all that's going on here, okay? That's a lot of text on one bad slide to say very little, because that's actually what we're doing, okay? All right. So then here we are again with our happy participants. What now happens is chicka 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 chicka. That's the same thing we just talked about. I think it is. We start with H2 with its address, right? Where I'm sending this thing. Yeah, it's the same thing.
The only thing that changes like the upper right-ish corner of this?
Like there?
No, not all of the bottom and the left side are the same.
Oh, I know what the issue was. Hang on a second. Yeah, it was the forwarding table. Okay.
Yeah.
Again, this should be like 10 slides to tell a story instead of one slide of, Picasso's Guernica or something, That's perfect, actually. Go look that up. Guernica. Then later on, share it on Discord. This is what these slides remind me of. It's a classic piece of art celebrating, I think, the Spanish Civil War. So anyway, so what we're talking about here is H1's forwarding table, right? Who does H1 give stuff to? Well, it's pretty simple. By default is to give it to R1, and if the subnet mask, if it's the subnet number, right? In other words, if the destination of the packet is the same subnet I'm sitting on, that's all this is saying, then I'm going to give it to the wire. I give it to the wire, okay? As the next hop is just my interface to the wire. And if it's not me, I got to give it to one of the routers I know. Oh, I only know one router. I'll hand it off to router number one right there. Okay? And then similarly, when it gets to R1, remember, I'm going here. When it gets to R1, R1 knows about two networks. It sits on two different networks. Literally, a wire comes into one card and a wire comes into another card on the same box, and routing software just looks at the two networks. It's got a foot in each world, okay? And subnet 128.96.34.0, remember, is this guy, and 34.128 is this guy, this blue line right here, this network. So R1 gets this packet, and it's like, oh, this packet is for 34.0. Oh, that's right here. That's this guy right there. I'm just going to put it on that wire. And if that's not the case, which goes out its own interface 0, if it's not the case and it says, that it's going to .128, then it'll put it on interface 1 right here, and it basically puts it on that wire. And then it still has kind of a default, which is, what is that one? 128.96.33.0, which is this guy. Oh, it's close enough that its routing table knows about this guy because it's like a hop away. So it knows about this one because it's propagated. And it goes, if this is headed toward 128.96.33.0, I'm just going to send that to R1, or sorry, R2, right? So you got it? I'm either putting it on this wire or I'm putting it on that wire for whoever it is that it's destined to, or I'm going to address it to R2. So when it gets to this wire, R2 will pick it up and everybody else will leave it alone. Okay? That's it. What changes here? Anything I care about? No. It's more like let's just bask in the glory of this piece of artwork. This is the part where the butterflies and the birds start to go and then the flutes come out. And then you know what happens next. Dun, dun. Okay, go ahead. An address that would not be on any of, well, yeah, it would be some rando 128.96.33.7, and none of the routing tables here know about it. And so based on the way the thing's been configured, it probably, there's a default. And the default's going to just be like, you know what? The edge of our little world right here is R2, or maybe there's another router, R3, somebody knows about, you know? Yeah, that's right. And after so many hops around, it kind of goes, bag this. Um, yeah, so there are some where it's like, I think that the best place, it's a little bit of that, like go to the end of the street and then ask. It's kind of like that, like I don't know, and nobody I know really knows, but the one that we all know is best connected is, is Biff over here. So as a default, if I don't know the subnet, I give it to Biff. And then Biff knows that if he doesn't know it, and it's not in any of his routing table, his default is to kick it over to so and so. And what to me is kind of cool algorithmically is that these routing tables they're just regularly refreshing. They're learning, and then modifying, and then stuff gets stale, gets kind of old, and it drops off. And they remove it from the tables. Have you ever like just brought up a domain name? Ever done it? Have you done that with your own domain? How many of you have done that? Like get your own domain and do something, just a few. But when you do that, which you hopefully will sometime or another, when you do it and you actually host it, any of the host services that you can use, right? GoDaddy or I tend to use DreamHost. It doesn't matter what it is. Um, when they host them, they'll actually say, uh, you know, leave up to like 3 days for the routing tables for the DNS servers. And there are servers out there that are called domain name services, right? That'll help you with some of the routing. And they'll be like, anybody know? I can go to like a little bit of a central clearinghouse, but it's not central. It's more just kind of like local to that area, right? We call these DNS servers. And they just know a lot. They're out there with the purpose of gathering information so people can query to get some ideas to help them. But to me, it's kind of weird that it even works, that it'll propagate for so far and then it'll stop. And then someone's got to move around almost by chance till it bumps into somebody that knows somebody that knows somebody that knows you. And then it can make its way. But it's not like a packet takes off from your laptop just knowing just right how to get to you. Like Google already mapped out its preferred route. It's pretty organic. Okay. So when we get to ARP, okay, or address resolution protocol, what we're dealing with there is the fact that everything we're talking about, notice that every discussion we've had has been about IP addresses, not about actual physical hardware. Because for one reason, you can bop around. We'll also learn that when it comes to IP addresses, you can statically assign them. Like I might just have a pool of IP addresses in my organization, right? Once you get to my subnet, who controls the rest of those IP addresses? I do. And I can assign them, you get one and you get two, you'll get five, and you're going to get, 14 or whatever. and we assign IP addresses or node addresses basically and if we're doing subnetting, to our subnet. Um, but you can also be in a situation like is traditional with an ISP, where you just kind of just say, I can do this dynamically. That's all right. Every time I log in, just give me one in your pool, and it can be different every day. That does mess you up when you get, because sometimes you can tell when like Wikipedia will track the IP address of who's making, who's vandalizing a website, and they can block. Sometimes they'll block that IP address. Like, sorry, you can't do Wikipedia anymore, and you're like, I didn't even edit Wikipedia. Well, it was somebody else in your neighborhood who was on your same ISP that was doing, what they're doing. But they can also, if it comes down to like, that's not, for example, a defense when it comes to, I don't know, espionage, child porn, any other, sort of reprehensible behavior where you're going to come in and go, well, IP addresses bop around all the time. You can't tell. Well, yeah, the ISP also knows that during the time period in question, yes, that was your IP address. So there are logs about what your IP address is at a given point in time, so the feds can still come knock your door down, right? So what we have is we're using this destination IP address to find your destination hardware address. So audience participation time. What's the point? And it's okay if this doesn't jump immediately to your mind. What's the point at which the destination hardware address finally becomes relevant? What's your thoughts? Or could even just be a guess, and it's okay if it's wrong. But I think there's enough information out there from what we've talked about to make that clear.
If it's, you've got nodes on the network that are checking the packets or passing it along if it's not for them. So if it's supposed to be for them, then it should look at the hardware and say, is this for you?
Okay, I think you're on the right track. Other comments related to this?
Yeah, I was kind of going the same thing. Like when the packet gets to the node, does that come relevant?
Okay, let's keep going, Seth.
It uses the MAC address, like the router uses the MAC address to assign IPs, and so it's relevant. I know because when you have two devices with the same MAC address, which is possible, then it has trouble assigning the IP, and it'll keep booting one of them off the server.
Some companies have like accidentally.
I mean, it would have to be an accident, or you're getting like bootleg stuff from somebody who's not even licensed to make it, Yeah, which is kind of going into the weeds, but.
You can, but it's not worth it.
No, it's like almost like you can. So
Correct.
Does it become relevant when it's on the router that's one hop away from the destination?
Yeah, I mean, everybody's on the right track and pretty much correct, except for this crazy story that Seth is trying to weave and get us to buy in. Yeah, this is a problem. But the MAC address isn't issued by a school. The MAC address is built in by the manufacturer. Has to be. So we got to see where they're buying their hardware from. No, but the bottom line is the physical address is relevant when you are physically attached to the physical wire. So when you're actually on the same wire and they're dropping it there for somebody to pick up, that's the point at which we're looking for my physical address to be. It didn't start that way, and it only got there on the last hop. So at the point at which I take this packet, and it's like this is my subnet. This is I'm touching the wire that goes with that subnet, and then at this point, I've got to go get the MAC address. Okay? I've got to go get the MAC address because now I need to send it definitively to the right piece of hardware. Don't even give me that look, Seth, because you're like, yeah, go ahead, knock stuff out, but it doesn't always work. Pshaw is what I say to this. It's an exception we can't afford to talk about. But no, you know what I mean? So I'm at that point where it's like, that's the right subnet. Okay, hey, ARP server, I got an IP address. What's the physical add MAC address that goes along with that IP address? And then you're on that physical wire and it just goes, yeah, here's the MAC address. Great, I rebundle the packet, but to the hardware address, and it goes, and I drop it on the wire, and then everybody on that wire sees, as you know from Networks One, or maybe you don't know because it was in a slide like that one, but everybody sees every packet when you're on the physical wire. Everybody sees every packet, so it just looks at it, senses it, and just goes, "Nah, it's not me." Okay? This is why things like security and encryption become so relevant. You know, if somebody's on the same Wi-Fi adapter as you, you're sharing a common network source, you can do things like sniff packets on that thing, you know, and see traffic at that level or anything moving through any wire that's going somewhere, right? Um, yeah, but at that point, that's the point at which I got to know what the destination hardware address is. Okay, which brings us to another happy graphic for the address resolution protocol. But I hope that demystified the crazy slides at least just a little bit. You know how much of my life I can never get back because of the service I've rendered to you today? Way too much. Okay, so address resolution protocol, ARP. I think it's also like the Association of Retired Persons. I'm starting to get mail. You know what I mean? That might be like AARP. I don't know. All right, so let's back it up again. Start with the picture, okay? The things that are relevant here. Here's our frame with an Ethernet, a hardware destination address. And here are forwarding tables. And here's our little happy network. And then there's some decision tree about how the protocol works. Okay, that's what's going on this slide. This not quite as busy as the other one's slide. So I've got network 2 is this guy. I've got network 3, which is this point-to-point network. Network 4, which is this Ethernet. Oh, and network 1, which is this wireless network that were shared on this access point. Okay. So that's our topology. All the H's are hosts or nodes, endpoints, right? And I've got H1 through H9, just nodes on these things. And the R's are routers again. Okay, what else is going on? We dropped, let me see, in this environment, yeah, we've just got the one slide. I'm just trying to remember the exact context because this is not a continuation of the previous one. It's a little bit of a shift. So it's basically saying that the IP destination was network number 4 and host number 8, right? So network 4 is right up here, right? That guy's network 4. So R3 at some point is going to receive this packet. That's kind of the bottom line as it's moving stuff around. And I think it may have been that it started over here. I'm going to take this assumption that we started with H5 and we're trying to send this IP packet 4.0.0.8 carrying stuff, which we don't care about. And at this point, we don't care what the Ethernet destination is because H5 looks at its own network address, which is network 1, and it just goes, if it's network 1, my next hop is, yeah, I'm on the same network. So, oh, sorry. If the destination is my network, then just put it on the wire. That's what interface 0 means. Just drop it on the wire or the wireless. That's not the case. So it goes, well, otherwise, I don't know, I'll just give it to R1. So it gives it to R1, which we don't have a forwarding table for. But in any case, R1's going to do a similar thing where it's going to receive it and it's going to go, well, it's not network 2. That's not our destination. So I'm not thinking too much about this. I'm just going to kick it over to R2. R2 does the same thing. Yeah, when I got this kind of thing, where's R2? It's not even here. When I do that same thing, it's like I kick it over to R3. R3 receives it. Then this is the part where we're relevant again. It's like if this packet is destined for network number 2, then I give it to R2. If it's destined for network number 1, I give it to R2 because network number 1 is back over here.
One is the wire.
Yeah, we're over here. If it's destined for network number 2, I give it to R2. If it's destined for network 3, which is this network right here, right? Then I just drop it on the wire. If it's destined for network 4, I drop it on the wire. Okay?
What does AP stand for?
Access point, I'm pretty sure. And then I'm trying to figure out why is that H5 or H? No, sorry, that's H1. H1 over here. Again, just an example, right, of the same idea. So then we get into what's going on here. Is the network part of the destination address equal to the network part of one of my interfaces? Okay? Meaning when I look at the wires that I'm actually connected to, is one of the wires I can see, like if I'm a router, the same network part of the address that I'm looking at. And if it is, then I get the hardware address at that point. That's when I get the hardware address. I build a frame, put the packet in, and I just deliver it to the final host. I put it on the wire addressed to the hardware address. Okay. And if you think about it again, someone's trying to get a letter to me and I'm moving around, right? Like at any given moment, there's a point at which you got to ID not just that I'm at a certain address or that I live in a certain place or that I go by a certain name. Some point you got to go DNA sample. This is my impersonation of a DNA sample. I don't know where that came from. Swab, DNA sample. Yes, it's you. Here's the package we've been trying to give you. Okay. That's the point. Okay. But if that's not the case, then is the network part of the destination address in my forwarding table? Do I know of this thing? I know of it. It's not right now, it's not right here, but somebody right here is the best person to handle it. And it's explicitly spelled out. So I do that. If so, then I get the corresponding IP address. Okay? But I've got to now deliver it. This is the part we haven't talked about before. I do have to deliver it physically to the router. This is why you're like, yeah, but that hardware address has been tagging along the whole time, right? Yes, but it's not the hardware address of the endpoint that you're headed toward. It's the hardware address of the next point. So in other words, if I say packet, destination, my subnet, I can touch it. Give me the hardware address. Put it on the hardware, put the hardware address in, drop it on the wire, and the node it's directed to is going to see it. But you're like, well, what if it's not my network, but there's a router that can maybe help me out? Well, then I need the hardware address of that router. I put that in the hardware address because there's always a hardware address driving the IP packet to the next point, to the next point, to the next point, and it's changing every time. The hardware address, so it's carrying the same IP address along with it, but it's changing every time. It's like that router sends it to that router, they send it to that router. The hardware address of those routers is changing.
Does the source address change too?
Say it again.
Does the source address also change?
No, it shouldn't. Well, no, it should. The source IP address never changes. Is there a source hardware address? I don't even remember.
I think in the previous slide.
Yeah, source hardware address. Yeah, no, I think that actually, and I don't know, I bet like $12, $13, 14 tops. that the source hardware address is also changing every time. So that this represents a hardware point-to-point across a wire, and then when this new router gets it, puts its own hardware address, because otherwise, how do you know how to reply back? How do you get, that's my guess, 14 bucks, $24 is the highest I'm gonna go.
Sorry, just to clarify, so both the source and the destination hardware addresses change?
$24 worth of confidence.
How does it know that it's reached the destination then if it's constantly changing?
Because the subnet or the network address, AKA in our case, the subnet address that we're looking at, is the one I'm touching. Like this is destined to this subnet and I'm touching it. I know that the destination node is also touching that same piece of wire. And I don't know if I've answered your, if I answered your question.
No, because I'm trying to figure out why it's even necessary if you're just using the IP addresses.
Why what's necessary?
Like, because if you're just relying on the subnet and a combination of the IP address to find out whether or not you're in the right loop, because it isn't the point of the destination of the hardware address to finalize it to the actual node within the subnet.
Yeah, well, one of the key things is that even though I said like my laptop had 5 IP addresses today, the subnet, like in the CS department, didn't change 5 times today. You know, so that is kind of it's stable and static. So if you send me an email that's addressed to my UVU at you know, whatever, CS, whatever I am, and it eventually, whatever, that's a bad example, but if I had a CS specific server or something, there is a point where there's a router that touches that subnet. And when you touch that subnet and you see that the destination subnet address is the one that I know about, even though it's still part of an IP address, I know that that's the right spot because those are static, even though the endpoints are moving around. At that point, it's a miracle is I think it's a Christmas miracle that any of this works. But that's the point at which I strip it down and go hardware. But I got to be on the same wire. And I don't know if that's helping. I'm now doubting everything I know. Down to $1.2 of confidence. I don't know.
Because to me it makes sense that the source would change, because then you know how to go backwards.
Right.
Like, hey, it came from this router, or it came from
Yeah.
whatever.
But that's a source hardware address because, like, if we're physically in this space here, and I say, "Tell me your first name." Dallin.
Yeah.
And I go, "This is for Dallin," right? And then Dallin goes, "What? I'm not sure I heard you correctly. Were you trying to say Dallin?" We're at this physical level. You know what I mean? We're not sending letters to each other. We're touching the same wire, and you know, figuratively. So that back and forth has to be physical to physical. If it has to kind of go all the way back, then I'm doing, you know, source IP addresses for like, where did that come from? Where did that come from? Yeah.
So the hardware addresses are for the step, the IP addresses are for the overarching.
Yeah, that's right. The hardware shows up kind of last step. But understand that everybody who receives a packet, including a router, that was for that moment the last step, even though they're an intermediate part of the whole big journey. They're still, it's like going to train stations. Oh, that's a good analogy, right? You go to a train station, there's all kinds of trains, right? You go to like, I don't know, we don't really have, in Utah, it's like down there in Provo with one track. But if you go to like anywhere in Europe, you know, you're looking out over whatever, Waterloo Station in London, and you're looking at track, lots of tracks, trains coming in, right? In the US, maybe airlines would be a better, you go to Atlanta or you go to Salt Lake, right? You arrive in Atlanta, you get off of your plane, you get, you know, on the next one, and you're taking like segment after segment to try to, you know, kind of make your way there. Only it's organic. But this process where we are trying to, so you see that, right? There's a point at which it's like, if it's the endpoint, I drop it on the wire. If it's meant to go to somebody who's going to pass it on, like a router, I change the address to the address of the router, drop it on the wire. Or Is there a default one? Then I get the hardware address of that router, drop it on the wire. And by the way, everything I'm saying is true of wireless or any other system. I'm just using the wire as the classic metaphor. And then it's like, if it's none of those, if I don't know it and you're not in my forwarding table and I don't have a default router, then you just hit a dead end. We got to shut it down. Okay. What's that?
How much in programming just works in an if-else sort of situation.
Wait, say it again. I didn't hear it.
It's how much in programming just works in an if-else situation. It's just like everything's just been kind of conditional.
Everything.
Yeah.
Yeah, exactly. Yep.
I think you also only use the MAC addresses if you're on the same network, so that it doesn't go through the router.
Yeah.
If you only have IP, then it has to go through the router to come back to the same network. But with the Mac, we can just send it through the wire to a different one.
Yeah. Well, you would, and if you only had IP addresses, you would lose all the resilience you need in the delivery mechanism, right? Because servers are going down, routers are going down, right? Everybody's going down. Okay, all this one does, and this is actually not too bad a slide. What happens is H1's trying to figure out, where to go, and when you broadcast this ARP packet or this ARP packet, there's also a packet called RARP, which is reverse address. It also sounds like RORO, but it's a RARP packet, and these ARP packets. Essentially, it's a packet with a certain format and an operation type that is recognized as being a query for certain kinds of information. And the ARP client just goes, "Hey, if you're H3 on Net2, could you send me your MAC address? I got a package for you." So it's also not just going, "Oh, I know what that is. I'm going to drop it on the wire." It's saying, and that might have happened to me this morning when I was in my home network, right? Then I'm on my phone. Now I'm in my office. Now I'm here. Every time I moved, it's possible that packets are still making their way to the other old IP address and bouncing on back, right? So at some point it's going to go, like right now, I'm sure I've gotten some emails while we've been talking, right? There was a point at which somebody on a local router had to go, "Hey, is this Chuck's laptop hardware Ethernet?" And like, "Yeah, could you send me your MAC address?" "Sure. Here's the hardware address." Now when you drop it on the wire, I receive it. Okay? That's it. And this is really critical. This is critical. ARP requests do not cross routers. They're on the same segment. It's like, "Hey, is there an IP address like this here?" Someone goes, "Yeah, that's me. Would you send me your MAC address?" "Sure." Now I can actually deliver that to you. Okay? It's kind of like, how do you facilitate the last step? Is really what it's about. Okay?
Does ARP only work on a broadband connection or a non-wireless connection?
No, I don't think so.
Or it does work wirelessly?
I'm not 100% sure, because most of what Wi-Fi does is physical layer connectivity to some access point, which is itself on the wire. It's like an extension of the wire. And then gory detail there, I don't know. But then over here, what you've got in this scenario, the ARP server goes, "Yeah, that's my MAC address," and it sends it back. So we send it out. Notice that this query goes out to everybody on the wire, and then the response only comes from one of them. Now we're out of time, but I just want to say this. We're going to come back. We'll touch these briefly or not. I just want to say this about DHCP. The only thing that's at issue, and we'll come back to it, is I can statically assign IP addresses, or I can say, "Why don't you give me one every time I'm on your network?" And I'm asking some server to give me that. That's it. And it's very common when you're using ISPs and things like that to use DHCP. It is the most common, unless you're in a static environment where that machine is always that one thing at that time, in that place. Okay. All right, friends. Is today's Wednesday, right? Yeah, so good riddance till Monday, vice versa, I'm sure, to the material. But no, and I'll try to look at the homework stuff so I have a sense of what you guys are suffering from. And I'll set up a Discord server for the class.